Hello students, welcome to another section of transistors, and today our topic is field effect transistors. In our previous videos we have discussed about the working principle of a transistor followed with a bipolar junction transistor, and today we are going to deal with another type of transistor, that is FET or field effect transistor. Like any other transistor, it is a four-terminal device that are source, gate and drain, which uses an electric field to control the flow of current through the device. The device has a high input impedance, which is useful in many electronic circuit applications. Now, field effect transistors are categorized into two parts. The first one is JFET, or we say it as junction field effect transistor. The second one is MOSFET, or we say it as metal oxide semiconductor field effect transistor. In this section, we will be learning about JFET in detail. Analogy. Let's take an example of water tap which is connected with a supply. At the time when we open the knob of the tap, the water starts flowing, and when we close the knob, the water gets stopped. The working of a field effect transistor can be compared with this. If we compare the water supply with the source terminal, the knob as a gate terminal, the nozzle of tap as the drain terminal, and the water as electrons or holes, it can be assumed that the flow of electron or holes can be controlled by adjusting the gate terminal. Theory. The basic concept of junction field effect transistor is based on the concept of attraction within a semiconductor channel. It is mainly operated by using an electric field effect, hence it justifies its name. A field effect transistor consists of a semiconductor channel with four electrodes, referred as drain, source and gate. The terminal gate is also known as the control electrode. It is placed near the proximity channel so that its electric charge is able to flow throughout the channel. At this point, the gate terminal controls the flow of carriers from source to drain, and it is done by controlling the size and the shape of the conductive channel. The channel in semiconductor where the current flow occurs is either P-type or N-type. The JFET device is categorized into two types depending on the type of their channel. The first one is P-channel JFET and the second one is N-channel JFET. In addition to this, there are two further modes of JFET. An increase in the voltage on the gate terminal can either deplete or enhance the number of charge carriers present in the channel. As a result, there are enhancement mode FET and depletion mode FET. Electric field is generated in JFET to control the flow of current in the channel. So the device is said to be voltage operated and it has high input impedance. And current is generated due to a single carrier, hence JFET is less noisy. There is a distinct advantage over the bipolar transistor which is operated in current. So it has much lower input impedance and two types of carrier are also present in there. So it has greater noise. Circuit operation. The circuit symbol of an N channel and a P channel JFET is shown in the figure. The arrowhead on the gate terminal indicates the direction of the gate current when the gate source junction is in forward bias condition. In case of a normal operation, the gate source junction is reversed biased. The schematic diagram of an N-channel JFET is connected with a voltage source, that is VGG, applying the negative side on the gate terminal while the positive in the source terminal. Another voltage, that is VDD, is applied to the drain terminal, and hence we can see that the current is flowing from source to drain. Now, static characteristics of FET. We have plotted the graph of drain current ID against the drain to source voltage VDS with gate to source voltage VGS as a parameter, and it is known as a static characteristics of an n-channel JFET. Here we can see the various curves that formed due to different gate to source voltages. In this plot, we can find three different regions. The first one is linear or the ohmic region. In this case, the voltage VDS is small and ID is nearly proportional to VDS. The next one is the saturation region. Here, the current ID is fairly constant and it is independent on VDS. The third one is the breakdown region. In this case, the drain current ID increases rapidly with a small increase in VDS. Well, that is all about this topic for now. And in this section, we have learned introduction to field effect transistors, types of field effect transistors, pinout and working principle of JFET, types of JFET based on channel, modes of JFET based on the applied gate voltage, circuit operation of an n-channel JFET, static characteristics of an n-channel JFET. Well, that's all. Thank you and goodbye.